Okay, this video is going to be on two-way contingency tables. And a contingency table are useful in showing the relationship between two categorical variables or determining whether or not there is a relationship. And I have to say this is an extraordinarily important topic. We're going to learn how to read the tables in this one. And when we go on to probability, which will be the next unit, we'll actually learn how to develop the tables. So this is something we're going to see more of, really important, and also there are SAT questions that match these. So we're going to talk about a few definitions, just a couple very easy ones. Marginal frequencies are the number of times a single variable resulted in a particular outcome, and it's going to be a total or row, a single row or single column total. And then the next one are our joint frequencies, and they represent the intersection of a row and a column. So basically, this is a single, and this is going to require two variables. So when we look at this table, we basically have two variables, which happen to be heart attack severity, which is right here, and either fatal or non-fatal. And then we have our other variable, which is cholesterol level, which is creatively low, medium, or high. So let's take a look at what marginal versus joint. So when I circle these, this is a single column total, single column total, single column total, a row total, and a row total. So these make up my marginal frequencies. When I look at the values in the center, this is combined of two things. So two things joined together, low cholesterol and non-fatal. So this group right here that's in the center of the table, represent our joint, and another word is conditional frequency. It's really the joint frequency, but we're going to talk about conditions later, and they relate to those values, all right? Because there are basically two things happening here. And since there are two things happening here, we like to say there's kind of an intersection, and that's the intersection symbol we'll talk about later. Well, one thing you should have noticed, if there's one number I didn't circle, and that was I did not circle the 112. That doesn't show up very well. I didn't circle the 112. Well, the 112, people will say it's the total, but that's true. But what's really important is to know that that is the actual sample size. All right, so that's my sample size. So how many variables? We've already said that there are two variables, which are heart attack severity and cholesterol level. And each one of those variables had the heart attack had two levels, which are non-fatal and fatal. And the cholesterol had three levels, which are just low, medium, and high. The next thing is the sample size, which we already said was 112. Then it says list the joint frequency. So we're listening for the combined, all right? And so we have a non-fatal and a low at 29, a non-fatal and a medium at 17, a non-fatal and a high at 18. We have a fatal and low at 19, fatal and medium at 20, and a fatal and a high at 9. Lastly, it asks for our marginal frequencies. And our marginal frequencies are, we have low cholesterol at 48, medium cholesterol at 37, high cholesterol at 27. And then we have non-fatal at 64 and fatal at 48. All right. So as we move on, the very last question is the one that's probably the one that scares people the most. And it asks, are the variables independent? Justify your response. Well, to be independent, they want to know, are they proportional? And as long as I have corresponding proportions, that's all I need to check. So I need to go, well, 29 over 48. Well, turns out that does not equal 17 over 37. And that does not equal 18 over 9. That does not equal 64. Oh, I skipped one. Hey, that shouldn't 18 not over 9. That should be 18 over 27. Excuse me. And 64 over 112. So it's not proportional. It's not proportional. So because it's not proportional, they're not independent, which means there is a relationship or association. Proportions are not the same, so they're not independent, and so there is a relationship or an association. All right. All right, continuing back with that same table, it says, what percent of the people in the sample had a fatal heart attack? Well, we had 48 people out of 112, so 48 over 112. And I want to know whether this was a marginal probability or conditional. Well, since it came from the margins, it's marginal. All right. What percent of people in the sample have low cholesterol? Well, it turns out 48 have low cholesterol out of the 112. So this is also a marginal. Moving on. Well, I have a little difficulty here. It says, what percent of the people in the study had a cholesterol level and had a 90 a non-fatal heart attack? So what percent of the people in the study had high cholesterol and a non-fatal heart attack? Well, here we have the word and. And anytime we see the word and, because and has an N in it, there's our intersection sign. All right, and that's the symbol for intersection. And what we're looking at had high cholesterol and non-fatal. Well, that's 18. That's where it intersected. What I mean by it intersected, if I were to circle this, I'd go, well, they want non-fatal and high cholesterol. There's my intersection. So 18 out of 112. And since I have two variables involved and not a singular, this is going to be a joint probability. Continuing on. What percent of people had a medium cholesterol level? So this, we're looking at this column, and had a fatal heart attack. So we have medium intersect fatal. So this is going to be 20 over 112, or 17.9%. Because it involved both variables, this is also going to be a joint probability. Now, the next section is probably the ones that you're most likely to see on the AP exam. And we're talking about conditional probability. A condition means that we have a restriction or condition. So in the previous ones, we were looking at the entire sample size. We were looking at the 112. Well, what happens if we know something? What happens if we're able to restrict it to a smaller subset of the sample? Well, that's what we're doing with a conditional probability. And typically, it's going to be the joint frequency, the two variables over one of the column totals or row totals. You're like, well, how am I going to recognize that? Well, it's generally said and or both over given equals intersection over given. And I'd also recommend you put intersection over given. That's the intersection symbol. Now, a couple things to point out. Most of the time, they're going to give you something like given, but they may say from the group, or if they're in the group, or out of the group. If they say those things, they're talking about out of the group of people that had a fatal heart attack. Well, obviously, they're only looking for the fatal heart attack group. So that means the same as given. All right, going to pause for a moment. Okay, so our question is, given that a person had a fatal heart attack, so basically what they're telling us is given that it came from the fatal heart attack column. So we're looking at this row right here. And because it says given, then our denominator, because remember, it's always going to be intersection over given, happens to be 48 as opposed to the 112, because we're only looking at fatal heart attacks. Given that a person had a fatal heart attack, what's the probability they had high cholesterol? Well, then I'm looking here, and see, it looks like I have two streets intersection. That's one of the nice things about that. So we go, oh, it's just 9/48. And that would be my answer. So now we're not talking it out of the 112, we're only taking it out of the 48. Given that a person had low cholesterol. So once again, now I'm looking at this column, low cholesterol. And remember, it's always intersection over given. So low cholesterol, there's only 48 of them. What's the probability they had a fatal heart attack? Well, that would be 19/48. Lastly, given a person had a moderate cholesterol level, so we're looking at the medium, so N over given equals 37 in the denominator, because we're looking at this column right here for the medium. What's the probability that they had a non-fatal heart attack? So non-fatal and medium would be, oh, there's my intersection at 17. So 17/37. All right. Lastly, it says, please complete the table converting using percentages instead of frequencies. So this is the same material, same table, except and no longer is it in the actual frequencies, because these were the frequencies that were given, 29, 19, and 48, 17, etc. You're like, well, how am I going to do that? And it's actually very easy. All we need to do is come back and divide all these values, all of them, by 112. So by the sample size. So if I divide all of these by 112, I can sit there and write 112 over and over again. I won't bore you with that. This is what I should get. Here I have an option of writing 100% or 1.0. Personally, I like 1.0 because it's helpful for probability, but that choice is yours. All right, this concludes this video. Thank you.